Hello everyone and welcome to this session. The session is about Lewis structures, but uh, before the main topic, I want to explain some basics like different type of atomic bonds and octet rule. As all we know, we have four different kinds of atomic bonds and including a single covalent atomic bond and double covalent atomic bond and again triple covalent atomic bond and finally coordinate covalent bond or dative bond. Number 4, coordinate covalent bond, and it's also called dative bond. But first of all, single covalent bond is formed when two atoms shared their single electron between the atoms. For example, I can refer to atom A, for example, that has single electron, and another atom B, for example, single electron, and when two electrons are shared between two atoms, the result is called single covalent bond. The most important point is that we can connect one single atom from atom A, for example, and another single electron from atom B. Another thing is double covalent bond, and double covalent bond is formed when four electrons are shared between two atoms. For example, when the atom A has two single electrons, and similarly atom B has two single electrons, we can connect one single electron from atom A by one single electron to atom B, and similarly another single electron we can connect together, and double covalent bond is formed like this between A and B, and triple covalent bond, triple covalent bond is formed when six electrons are shared between two atoms. For example, atom A that has three singlet electrons, and similarly atom B, we can connect singlet electron together for forming covalent bond, and the result will be a triple covalent bond, and finally dative bond or coordinate covalent bond. Of course, a little bit different from covalent bond because electron pairs are donated by one atom, and another atom brings no electron, like this when atom A has one pair electron and atom B has empty place, and one pair electron are donated by A, for example in this example, and it's called dative bond, and of course these four type of bonds is known in chemistry between atoms. But another important things is octet rule. The octet rule indicates the tendency of majority of atoms, like main group atoms, for example, that want gain 8 electrons in their valence shell. In other words, majority of main group elements are tendency to gain 8 electrons and have electronic configuration like noble gases, of course exception for helium, and in this situation they are more stable. And finally I want to explain how we can draw loose structure of atom. I can divide the main topic into two different groups, loose structure for diatomic or biatomic molecules. As all we know, in this case we two atoms like hydrogen gas or oxygen gas or nitrogen gas, etc., etc., and multi atomic molecules like NCl3, nitrogen tetrachloride, and ammonia, and I don't know, water, and lots other examples of multi-atomic molecules. Before everything, we must know about the electronic configuration of atom in periodic table. For example, hydrogen, the atomic number is 1 and electronic configuration is 1s1, and it has only one electron in its valence shell. Or for another example, nitrogen, atomic number 7, as all we know, nitrogen is from group 15, and electronic configuration will be 1s2, 2s2, and 2p3, because 2 plus 2 plus 3 is equal to 7, and in its valence shell we can see 5 electrons, and as a result the electronic configuration for hydrogen is 1 electron, and for nitrogen is 5 electron. We can replace electron in an atomic symbol of nitrogen: 1, 2, 3, 4. In first step, we must replace the electrons in a singlet form, and the final one will be pair, and as a result the nitrogen has 1 pair electron and 3 singlet electrons. As we can see, the electronic configuration of nitrogen atom, and our oxygen is 8. As a result, the oxygen from group 16 or 6a, and it has 6 electrons in its valence shell, and we can draw 1, 2, 3, 4, 5, and 6. It has 2 electron pairs, and also 2 singlet electrons in its electronic configuration. And finally, I want to explain how we can draw the Lewis structures for firstly diatomic molecules, and secondly multi-atomic molecules. For example, for hydrogen gas H2, 1 hydrogen is 1 electron, and another hydrogen also similarly has 1 electron, and as I said before, we can connect the singlet electrons and form single covalent bond, and as a result the Lewis structure of hydrogen will be this, and the most important point is that hydrogen don't follow the octet rule. The hydrogen follows doublet rule, and always forms 1 bond and reaches to double electron in its valence shell, and it follows a doublet rule. But for another example, we can refer to N2 nitrogen gas. We have 2 nitrogen, 1 nitrogen and another from group 15 or 5a, 1, 2, 3, 4, 5. There is no difference. We can replace pair electron in other places. As all we know, there is no difference between the places of pair electron or single electrons, and another nitrogen similarly has 5 electrons in its valence shell, and as I said, we must attention to octet rule. I connect 1 singlet electron I connect one single electron to another, and I count the electrons for each nitrogen in their valence shells. For nitrogen, for example, 1 or 2, for example, of course, the nitrogen 1 has 2 because one bond is calculated 2 electrons, 2, 4, 5 and 6, because the nitrogen hasn't reached to octet rule. I have to form another bond, and we connect another bond, and again we count electrons 2, 4, 6 and 7, and due to octet rule I have to form another bond, covalent bond, and again 2, 4, 6, 8, 2, 4, 6, 8. As a result, the Lewis structure of nitrogen gas N2 is N, 1 per electron, and triple covalent bond, and another nitrogen, and another per electron, and we can draw the Lewis structure of nitrogen gas as you can see. Of course, we can draw lots of examples, but I want to explain the Lewis structure of multi-atomic molecules, and the most important things, first of all, is the choosing the central atom in multi-atomic molecules. We must select the central atom. The central atom is the atom that must be in the central of atoms, and other atoms must be around of it, and the rule for selecting central atom is that the atom that has the least electronegativity, or in other words, when we want to display in periodic table the atom that is located in the left side, and the bottom is the central atom. Of course, there are some exceptions, like N2O, nitrogen monoxide, and in this case the nitrogen is the central atom, but in many cases we can find out which atom is the central atom, and in my view it's so easy. Anyway, I want to explain different cases of multi-atomic structures of molecules for multi-atomic molecules. For example, nitrogen trichloride. It can be seen that nitrogen must be central atom. It has less electronegativity than chlorine, and nitrogen from group 15 with atomic number 7, and chlorine from halogens group from group 17, and it has 7 electrons in its valence shell. As a result, based on the formula, we must draw 3 chlorines and another chlorines. As you can see, each chlorine has 7 electrons, 3 electron pairs and 1 singlet, and the side chlorine similarly, and we can connect singlet electrons, and then we count 2, 4, 6, 8. It has reached to octet rule, another chlorine, and 2, 4, 6, 8, and similarly 2, 4, 6, 8. As a result, the Lewis structure for nitrogen tetrachloride will be 1 per electron, and other 3 colors in different places around the nitrogen as a central atom, or ammonia in H3, whereas hydrogen cannot be a central atom because only has 1 electron. It's so natural that nitrogen be the central atom with 5 electrons, and hydrogens are around the central atom, and it's so easy that the drawing the Lewis structure of ammonia NH3, or for water H2O, again oxygen, the central atom, that has 6 electron, 1, 2, 3 from group 16 or 6A, and the hydrogens, and we can connect singlet electrons, and finally I want to explain one example that has dative bond like SO2, sulfur dioxide, and it's so obvious that sulfur is a central atom, sulfur from group 16 or 6A, and it has 6 electrons and 1 oxygen in one side, and another oxygen in another side, and I connect the singlet electron to another, and as I said before, then we must count the number of total electrons around the oxygen, for example 1 or 2. The numbers is not real. We can change the number, and 2, 4, 6, 7, and this oxygen number 1 hasn't reached to octet rule yet, and I have to form another covalent bond, 2, 4, 6, 8. It's okay for reaching to octet rule, but there is a problem, and we can see the oxygen number 2 has 2 singlet electrons, but sulfur has no singlet electrons in their electronic configuration, and we must replace one of singlet electrons to another place, and the empty place will accept the electron pair that donated by sulfur, and we can see a dative bond. As a result, the Lewis structure of sulfur dioxide will be S and O with 3 electron pairs, and double covalent bond by another oxygen, and 2 electron pairs. And in the end, I want to appreciate your attention.